In the second section of this chapter, we're going to focus our time on a proportion. So doing a full-on hypothesis test dealing with specifically with proportions. So we have three objectives. State and check the random 10% large counts conditions for performing a significance test. Calculate the standardized test statistic and p-value, and then perform an entire significance test. So in the previous section, we talked about stating the hypotheses and then the p-value and conclusion. Here we're going to put in the middle parts, the state. We have the plan portion where you're checking your conditions, and the do portion where you're actually calculating the values. And then the last part was your conclusion. So then what we're going to do is take it and do an entire significance test from beginning to end. So this section is going to be broken up into 3 videos. One where we're introducing all of the conditions and how to do how to calculate the standardized test statistic and the p-value. Then there will be a video on doing an entire significance test. And then there'll be one last video that is dealing specifically with a two-sided test or a two-tailed test. So when we perform a significance test, we do have the conditions that are the same from a confidence interval, random, 10%, and large counts. But now when we're doing this, remember we have 2 hypotheses. We have a null hypothesis and we have an alternative hypothesis. So when we're using our p-value in these conditions, it is important that we are using the null hypothesis, the claimed value. Remember, in a hypothesis test, we are assuming that the null hypothesis is true, so then that means the p-value that we're using in our conditions should be that claimed value. So we want to make sure our data come from a random sample, that our sample is less than 10% of the population, and our large counts rule that n times p and n times 1 minus p are both at least 10. So here, according to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out a test at the alpha is 0.05 significance level, where the null hypothesis is p is equal to 0.25, and the alternative that's less than 0.25, where p is the true proportion of all students at the school who have a part-time job. So they select a random sample of 200 students from the school and find that 39 of them have a part-time job. Check the conditions for performing the significance test. So is it a random sample? Yes, we had a random sample of 200 students from the school. 10% condition. 200 is less than 10% of students in a large high school. Remember, we're thinking like a 5A, 6A public high school where there's like 2,000, 3,000, 4,000 students. Large counts. We can see that 200 times 0.25 and 200 times 1 minus 0.25 are both greater than or equal to 10. So the conditions are met. So when we're thinking about those conditions, remember those all help us with the shape, center, and spread. So shape comes from the large counts rule. The center is that claimed value. Here was the basketball free throw example. And the spread, the variability, comes from the standard deviation formula. We will be using that same claimed value for p when we're calculating standard deviation. These are all things that came from sampling distributions that we then use for confidence intervals that we are now using for significance tests. So the basketball player example was saying he was a 80% free throw shooter, but we think that they're exaggerating. So the null hypothesis was that p is equal to 0.8, and the alternative is that p is less than 0.8. So if the null hypothesis was true, you have your center at 0.8. Remember, he made 32 out of the 50 free throws, so we have 0.64. So we're looking for this p-value. So that's where we find the test statistic. So when we're dealing with proportions, we're using z. So remember, it's the statistic minus the parameter divided by the standard deviation. Well, the statistic is the value that comes from your sample, so that was the 64%, 0.64. The parameter is that claimed value. The claim was he was an 80% free throw shooter. And then our standard deviation, the square root of p times 1 minus p over n, So then we have to calculate using the claim value. Then you have your test statistic, your z-value in this case. So then you can find the p-value using either the table or your calculator. Same things that we've done before. So using the table, we get 0.0023, and using our calculator, 0.0023. Remember, on the exam, calculator speak or language is not accepted as justification. So make sure you provide adequate information. All right, so here we're going to perform a test. In the preceding example, an administrator at a local high school decided to perform a test at the alpha is 0.05 significance level. This is the proportion who hold a part-time job. So let's jump down to the actual questions. Explain why the sample result gives some evidence for the alternative. Calculate the standardized test statistic and the p-value, and then what conclusion can you make? Well, the sample proportion, there were 39 out of the 200 that had a part-time job, which comes out to 0.195. That's less than the national proportion. That's suggesting that we have evidence against the claim or evidence for the alternative. Calculate the test statistic. So we take that sample value, 0.195. We subtract the parameter, which is the claimed value of 0.25, divided by that standard deviation. So our test statistic is negative 1.80. Now we need to go into what the p-value is that corresponds to that. So using your table, we get 0.0359. Or using your calculator, we get 0.0359. So now part C, what conclusion could you make? This is where we have to compare the p-value to alpha. So because the p-value of 0.0359 is less than alpha, which is 0.05, we reject the null hypothesis. We have convincing evidence the true proportion of all students at this large high school who have a part-time job is less than 0.25.